Section 8.5, multiplying and dividing radicals. So we're going to begin here by looking at expressions when we have radicals inside and outside of parentheses being multiplied by each other. We'll start with the most basic, and that's when we have a monomial, a single radical term being multiplied by a polynomial, two or more terms involving a radical. So just like any time you have something out in front of a parenthesis with no operation in between them, you need to distribute whatever's out in front to all the terms inside the parenthesis. So in this case, we need to take the square root of 2 and distribute it, multiply it by the square root of 10, and multiply it by a negative 5. Okay. When we do that, I'm just going to write out here the actual product. We're going to multiply square root of 2 times the square root of 10, which we can combine, and then plus the square root of 2 times, we have to think of that as a negative 5 since it's minus 5 inside the parenthesis. Okay. Using our rules with product rule with radicals, square root of 2 times the square root of 10 gives us a square root of 20. And then square root of 2 times a negative 5, we really can't do anything with that. Just we can write that as minus 5 square roots of 2. So we usually put a number out front of this root and keep the root second. I guess when you get to this point, technically you're done, although you could try to break down that square root of 20 to see if you get a like term, something that ends up with a square root of 2, so that we could combine it with that. But if you try to break that down, that would equal the square root of 5 times the square root of 4. Square root of 20 would. And we could square root 4 to get 2, so our expression would end up being 2 square roots of 5 minus 5 square root of 2. And that, of course, we can't combine because they're different values underneath the square root. So it really doesn't matter. We could have stopped here with a square root of 20 minus 5 square roots of 2. Okay? So either that or that are technically both correct. I think my math lab homework assignments will accept either. So that's just your basic distributing. But what if you have a binomial times another binomial, two parentheses expressions involving radicals with 2 terms each? Well, then we do the FOIL method. Okay, multiply all the 4 products, or the box method, if you remember when we looked at it as that way. So doing this now, we'd have to take the 7 and distribute it to both. 7 times 4 square roots of 5, and 7 times the square root of 2. Then we'll be taking a negative square root of 3 times 4 square roots of 5, and a negative square root of 3 times the square root of 2. Okay. So writing all of those products out now, we have 7 times 4 square root of 5 plus 7 times the square root of 2 minus, well, for now we could just, well, yeah, we can think of it as plus a negative square root of 3 times 4 square roots of 5, and a negative square root of 3 times the square root of 2. Okay. So now we just want to clean this up a little bit. First term, first product, 7 times 4 square roots of 5, we can turn that into 28 square roots of 5. Plus the 7 square root of 2. And we multiplied those, that just became 7 square root of 2. We have a negative square root of 3 times a positive 4 square roots of 5. So anytime you have a negative times a positive is going to give you a minus. We keep the 4 out front, but we can go ahead and multiply the roots. Square root of 3 times the square root of 5 will get us the square root of 15. And same idea over here. A negative times a positive is going to give us minus, and the square root of 3 times the square root of 2 is going to give us the square root of 6. Alright. At this point then we would want to see if anything would break down or if we can combine any like terms. But here we have a square root of 5, a square root of 2, a square root of 15, and a square root of 6. They're all different values underneath the root, so we would not be able to combine any of those. And even if we tried to break them down, square root of 15 is 5 and 3. Well, none of those are square rootable. Same thing with 6. That breaks down into 3 times 2, but neither of those were square rootable, so it doesn't help us any. So that actually would be our final answer. 28 square roots of 5 plus 7 square roots of 2 minus 4 square roots of 15 minus square root of 6. Okay. Looking at the next example is going to bring up a pretty helpful thing, is that when we're multiplying square roots, another binomial times a binomial, if they're almost identical, just the difference being their signs, one being addition, one being the difference, plus and minus, you're going to see what happens here. We end up getting rid of our roots. So when you get a final product. So let's go ahead and use the FOIL product, or the FOIL property. Square root of 10 times square root of 10 will be our first product. Okay. Plus square root of 10 times a negative square root of 3. Okay. Now we need to distribute that square root of 3 to both. So square root of 3 times the square root of 10, and then square root of 3 times a negative square root of 3. Okay. So now actually simplifying all of those products. Well, here we have square root of 10 times square root of 10, which will get us the square root of 100. Square root of 10 times negative square root of 3 is going to give us minus square root of 30. But here we have the same thing, only it's going to be positive. So 3 times 10 will give us, again, the positive square root of 30. And you see those are going to cancel each other out because of the same exact expression, just one's positive, one's negative. And last we have a positive times a negative is going to give us a minus. Square root of 3 times square root of 3 gives us a square root of 9. Alright. So again here, a minus square root of 30 and a positive square root of 30 cancel each other out. Square root of 100 ends up giving us 10. Square root of 9 gives us 3, so 10 minus 3. And our final answer is 7. Okay. So a couple things to take note of. You end up, when you multiply, again, two roots, the sum of two roots times the difference of those same two roots. We call these conjugates. We're going to get to those here in a little bit later in this section, and it ends up canceling out your roots. Because also, the square root of 10 times the square root of 10 gives us 100, but then when we square root it, it gets us right back to 10. Same thing with the square root of 3 times the square root of 3 ends up just giving us 3. Because it gives us a square root of 9, which when we square root gets us back to 3. So it ends up being helpful in what we're going to get into here a little bit later. Okay. Alright, next expression. We have the square root of 7 minus 3, that whole value squared. We have to remember, when we square something like this, we do have to square the entire value, the entire expression, which is the same thing as having two parentheses 7 minus 3 factors that we're multiplying by each other. So once again, we have to use the FOIL property. Oh, sorry, I'm off the screen. So saying here, square root of 7 minus 3 squared, we end up having to multiply two of those parentheses factors. So we have to use the FOIL property. So writing out the products here, we're going to have square root of 7 times the square root of 7. And we distribute. Then a square root of 7 times a negative 3. Then a negative 3 times the square root of 7. Then a negative 3 times a negative 3. So here we could write this first term when we now simplify the products as the square root of 49. But remember, it's just going to bring us right back to 7 once we take the square root of 49. So square root of a number times the square root of that same number is just going to give us whatever number's under the radical. Okay. Then here we have the square root of 7 times negative 3. We'll get minus 3 square roots of 7. And then another here, minus 3 square roots of 7. So those aren't going to cancel each other out. That'll actually end up becoming minus 6 square roots of 7. And then the last product, negative 3 times negative 3, gives us a positive 9. Okay. But we can combine those two middle terms as well as the 7 and the 9. So 7 plus the 9 will give us a 16. And then a minus 3 square roots of 7 minus another 3 square roots of 7 gives us minus 6 square roots of 7. That would be your final answer now. So all these examples we've looked at so far have all had number values that we were taking products of. Our next example, really make sure you understand the idea because it just uses variables. So we have the square root of k plus square root of y times the square root of k minus the square root of y. And again, they're the exact same things, only one is plus the roots, one is subtracting the roots. So it's going to be like the example 2 above where it kind of canceled out our roots here. So again, using the FOIL property, square root of k times square root of k plus square root of k times a negative square root of y and now distributing the square root of y, we have square root of y times the square root of k and a square root of y times a negative square root of y. So, looking at these, we could take this into, combine these two. Square root of k times square root of k would equal the square root of k times k would give you k squared. But those square root and that square will cancel each other out, and that'll just get us back to k. Just like above here, square root of 7 times the square root of 7 just gives you 7. Square root of k times square root of k really just equals k. But I'm showing that in between step there. Okay, we have a positive times a negative. This is going to give us a minus. Square root of k times square root of y is just going to be the square root of ky. Over here they're both positive, so it's going to be plus. Again, it's going to be a square root of ky. Now in the end here we're going to have positive times a negative, so minus square root of y times square root of y is going to be the square root of y squared. Although that will just simplify back to being just a y. So simplifying what we have, square root of k squared simplifies just k. Then we have two terms in the middle that are identical, except they're just opposite signs, minus and plus, so those are going to cancel each other out. And minus the square root of y squared, well, that just simplifies to minus y. Because the square root of anything squared, the root and the power cancel each other out. Over here the root and the power cancel each other out, leaving you with just k and y. So k minus y. And that would be your final answer on that one. Okay. Now last expression, we have a root here, or we have two binomials involving roots, radicals, but it's not a square root, it's a cube root. Just make sure we understand how that works. It's not exactly the same. It is a parentheses binomial times a binomial, so we once again use the FOIL property. We have 5 times 5. 5 times a cube root of 4, so plus 5 times cube root of 4. And then on the inside here, a negative cube root of 4 times 5. And then the last piece, a negative cube root of 4 times a positive cube root of 4. So simplifying that up, 5 times 5 gives us 25. We don't have any roots or anything to worry about on that part. Here we're going to get 5 cube roots of 4, and here we're going to get minus 5 cube roots of 4. So those pieces still cancel each other out. We don't have to rewrite those. And over here we have a negative times a positive. So we're going to get a negative. But it's not going to just give us a 4, like up here, how the square root of 7 times the square root of 7 gives you 7. When you're dealing with cube roots, you would have needed 3 of them. 3 cube roots to cancel each other out. Here we have a cube root of 4 times a cube root of 4. It is going to be negative, but that's going to give us a cube root of 16. Okay. And the cube root of 16 is not, it doesn't give you back to 4. Matter of fact, there is no number. You can't cube root 16 to get a whole number. Because 2 cubed would give you 8, and 3 cubed would give you 27. So there is no whole number. 16 isn't a perfect cube. So really on that one, there's nothing we can do to simplify. We'd be done right there. Okay. But just kind of to add to what I was saying, if we had a third cube root of 4 here, that would have given us the cube root of 4 times 4 times 4, which is 16 times 4, which would have been 64. If we had the cube root of 64, that equals 4. Okay, so you would have needed 3 cube roots of the same thing to get you back to 4. But that's not what we had, so we don't need to worry about that. That's kind of getting ahead to what we'll be looking at here in a second. Okay. Flipping over to the next page. We're going to look at rationalizing the denominator. Okay, so with these roots, when we have a fully simplified answer, we can't keep a root in our denominator. So if we get to something like this where we have an answer that is 1 over the square root of 2, we cannot keep our answer that way because we have to get rid of the root in the denominator. Okay? So 1 over the square root of 2, we have to think what would we need to multiply in the denominator to get rid of that root. Okay? So 1 over square root of 2 is equivalent to saying 1 over the square root of 2 and then what could we multiply by? And what we just looked at and kind of witnessed in those last examples, so you multiply a square root of something times the square root of that same thing, it would just give you the value under the root. So square root of 2 times the square root of 2 would just equal 2. But remember with a fraction, if you multiply by something in the denominator, you have to multiply by that same thing in the numerator to make sure you still have an equivalent fraction. Okay? So this would equal square root of 2 times 1 is square root of 2. And then the square root of 2 times square root of 2 just equals 2. So saying 1 over the square root of 2 is going to give you the exact same value as the square root of 2 over 2. If you evaluated either of those on your calculator, both are going to give you the same decimal. Okay, I think it's 0.7 something. Okay, and then this is our right. We are allowed to give a final answer that has a root in the numerator. Okay. Seems a little weird, maybe seems a little dumb, but just something in math that we we always have to follow when giving our final answers. Okay. So remind yourself why that worked. We can always multiply a fraction by the same number in the numerator and the denominator. So as long as we're multiplying by the same number in the top and the bottom of the fraction, then it's okay. And that is going to be rationalizing the denominator. Okay, getting rid of the root that's in the denominator. Alright, so looking at our first problem that we'll need to rationalize, we have 5 square roots of 2 over the square root of 5. So we want to get rid of that square root of 5 in the denominator using the same idea we just did above to multiply a root by an identical square root. That's going to cancel it out in the denominator and the numerator. We have to do the same. Okay. So if we actually multiply through here, square root of 5 times the square root of 2, we can turn that into the square root of 10. So we're going to have that 5 out front and keep that as the square root of 10 over square root of 5 times square root of 5 gives us 5. Okay. But then that we actually can simplify because we have a factor of a 5 in the top, in the numerator and the denominator. We can cancel those 5s out. So that leaves us with the square root of 10. Alright. Looking at the next example, we have a negative 16 over the square root of 32. So, let's use the same idea. Multiply by the square root of 32, numerator and denominator. Okay. So, just doing this, we can simplify this product. We end up getting, let's take this over here, negative 16. Square root of 32, we can start to break that down actually. So it's all going to be over a 32. But the square root of 32 up top we can turn into the square root of 16 times the square root of 2. Okay. So then this becomes negative 16 times 4 times the square root of 2 over 32. So multiplying in the numerator, 16 times a 4, or negative 16 times 4, gives us a negative 64, square root of 2, all over 32. And then that we can simplify. 32 will actually go into 64 evenly. 32 goes into 32 one time, 32 goes into 64 twice. So we end up with an answer of minus 2 square roots of 2 over 1, which we don't need to write because any fraction over 1 we really can just write as a whole number. So we can just keep our answer like that. Negative square root of negative 2 square root of 2. Alright. And then looking at our next example, a little more tricky to have to come up with, I guess, how to simplify this one. Probably want to clean up this whole expression first to see really what do you have in the denominator before you start determining what you're going to multiply by. Because we can't just multiply by, I don't know, p to the 5th. We have to really take this root to each piece.